GMAT all day.
Continuing where we left off, let's do one more problem talking about inequality properties. This question says, if x is a positive integer, is a greater than c? So here, really, again, have no choice but to look at the statements. They give me some information about x, and then they ask me about a and c, and I don't even know what the hell a and c are. So hopefully the statements will tell me. So statement 1 says a times b to the 2x greater c times b to the 2x. So same theme as before. Can I divide each side by b raised to the 2x? Because if I can do that, that makes this question easy. And so to know that, I need to know b to the 2x cannot be equal to 0, and I need to know its sign. And so let's see, can b to the 2x be equal to 0? And it cannot be, because if b to the 2x were equal to 0, our left side would not be greater than our right side. They would be equal to each other. And so that checks off first part of our inequalities checklist. And then the second part is, if I want to divide each side by b to the 2x, I need to know its sign. And so do I know its sign? So what determines, in here, we need to know our exponent rules. What determines the sign of our exponent? Well, it's the even or oddness. I believe the proper term is the parity of your power, because we know that our exponent cannot be equal to 0, because the base cannot be equal to 0. So it has to be positive or negative. And what determines that is going to be whether the power is even or odd. And because we know x has to be a positive integer, 2x also has to be an integer, and 2 times any positive integer is going to give you an even integer. And therefore we know anything raised to an even integer, this is just our basic exponent properties, anything raised to an even integer other than 0 is going to give you a positive number. And so we actually know the sign of b to the 2x. It will be positive. And that's for two reasons. It's because we know our base is not equal to 0, and because we know x has to be a positive integer. So given that we know the sign, we know b to the 2x is positive, therefore we know that we do not have to flip our sign, and we can divide each side by b to the 2x. And statement 1 is actually telling us a is greater than c, which is what we had been hoping we could do in our last few videos, but we're unable to. So it's not always the case that the GMAT is forbidding you from doing something. It's sometimes you can, by taking a close look at something, they're actually permitting you to do something. So statement 1 is sufficient. Dream scenario, 3 of our options are eliminated. Now what about the second statement? This now says a times b to the 3x is less than c times b to the 3x. So same thing, we want to divide by b to the 3x. Now, if we were to do that, you should know that you did, even if you didn't know anything about your inequality rules or your exponent rules, if we were to divide each side by b to the 3x, we would get a is less than c. And that would be contradicting your first statement, which told us a is greater than c. So data sufficiency, that should never be the case. Your statement should never be contradicting each other. So if that would happen, you should know something is wrong. So let's see, do I know the sign of b to the 3x? Now I know nothing about b, right? I know nothing about the base. The only thing I know something about is x, and all I know is x is a positive integer. So what that means is x can be even or odd, and therefore 3x can be even or odd, and b can be anything. And so even exponents or even powers are always positive if the base is not equal to 0, that is, which we know it is. Odd powers retain the sign of the base. So because 3x can be even or odd, and b, so the base can be positive or negative, That means b raised to the 3x can be positive or negative, and we cannot divide by it. And so is there anything else we can do? What happens if we do the same thing we had been doing in our previous video? So subtract. We can't really, you can't subtract b to the 3x from each side, but you can subtract this whole thing, c times b to the 3x. So a times b to the 3x minus c times b to the 3x. It's less than 0. We can then factor out of b to the 3x times a minus c is less than 0. So how do we get? We'll multiply two things to give us a value less than 0. So those two things must have opposite signs. So either we have a positive times a negative, or a negative times a positive. So a minus c could be less than 0 or greater than 0. If a minus c is less than 0, so that's this scenario here, that means c must be greater than a, right? If a minus c is positive, that means a must be greater than c. And so, given that, this here, your proof that our second statement is insufficient, and A is our answer. So we'll do one last inequalities videos combining everything we've learned.